Finishing up with reflections. Now this again, I already gave these to you. You're not going to have to write this out, but the key equations that we have for both of these here. For reflection across the x-axis is negative f of x. So whenever we have a reflection across the x-axis, we're going to use the general form of negative f of x. And when we reflect it across the y-axis, we're going to have f of negative x. And these are the two general forms we're going to use for both of these here. So if it talks about a reflection across the x, we're going to use negative f of x. If it talks about a reflection across the y, we're going to use f of negative x. We're going to use one or the other for these two here. Now again, it's going to make more sense when we actually do this here. So for this here, we want to let f of x equal the absolute value of x plus 3 plus 1. Write a function g whose graph is a reflection in the x-axis of the graph of f. So our new function is going to be g of x. Now we're talking about it being reflected where? Reflection in x-axis, across the x-axis. And the general form for being reflected across the x-axis is negative f of x. Questions on this so far? So we have the general form. Since across the x-axis is negative f of x, we put it there. Now, since we haven't done anything to the parentheses with our f of x, it's still just the function itself. We'll replace it with its function. So our f of x is going to be replaced with our absolute value of x plus 3, absolute value of x plus 3 plus 1. Questions on this so far? Now the next step is to distribute the negative. Now we're not going to multiply the negative inside the absolute values, but we're going to multiply it by the number in front. Well, since there's not a number written in front of the absolute values, it's understood to be 1. And if we multiply it by a negative, it just becomes negative, or essentially the absolute values is now negative. Absolute value of x plus 3. Negative stays in front. Questions on this here? Now we're going to have to apply it through the whole thing, so we're also going to have to multiply this negative by our positive 1, which will make it negative 1. Questions on this here? That's it. Because there are no like terms, the negative 1 and positive 3, we can't combine them. The negative cannot be transferred inside the absolute value, so that is the final answer. And if we want to look at the graph of it, math, absolute value of x plus 3 minus 1, we get this here. Y equals negative, not alpha, math, absolute value of x plus 3 minus 1 that should have been plus 1 graph. Okay. Well, you can see it is reflected across that x-axis. and it is the same distance. But that's all we have to do for this here. So how do we feel about reflecting across the x-axis so far? We good with this here? Bless you. Let's look at the next one. Write a function h whose graph is a reflection of the y-axis of the graph of f. So h of x is our new name. So x plus 3 plus 1 is our normal function. I just rewrote it here so that we can see it a little better on the screen, because the one in the note sheets is a little farther up. Now this time we're wanting to reflect it across the y-axis, not the f. Yeah. Mm-hmm. Well, the general form for this here is f of negative x. So across the x-axis is negative f of x. Across the y-axis is f of negative x. Questions on how we got the two forms? We feel good on these here? Well, inside the parentheses is not f of x anymore. We have f of negative x. Just like we did yesterday or on Friday with left to right, how we replaced every x with that x minus h. Here, we're now going to replace every x with negative x. So this x here is now going to become negative x. So we'd still have the absolute value, but instead of just x, we now have negative x plus 3 plus 1. Questions on how we did this here? Is there anything in front of the parentheses with that negative x? Well, no, so we don't need them anymore. So we can drop those parentheses, telling us that we have the absolute value of negative x plus 3 plus 1. And that's a reflection across the y-axis. And since there are no like terms, that's it. And it can be a little odd because we're not ending up with a number, a numerical answer, just one value. We're ending up with these equations. So it is a little different than what we're used to, but this is indeed the final answer. Questions on this here? We good with this here? Now I'll go on and graph it so we can see this here. So the one in blue is our original function. So the one in black is going to be the new function with it reflected across the y-axis. As we can see here, they are indeed mirror images of each other across that axis. So we have this here. We ready for the next one? More reflections. Let f of x equal the absolute value of x minus 5 minus 4. Write a function h whose graph is a reflection in the x-axis of the graph of f. So across the x-axis, the general form is negative f of x. Negative f of x. It's just the general form for a reflection across the x-axis. Now, since it's still f of x, we can just replace f of x with its function, because this here still matches up f of x and f of x. So it still equals our absolute value of x minus 5 minus 4. Now the last thing we need to do is distribute the negative through. So we multiply the negative by the absolute values. The negative is just going to multiply by the number in front of it, which in this case is 1, just making it negative 1. Now we don't have to write negative 1. We can just write negative in our absolute value. But we also have to multiply the negative and the negative 4. And our negative times negative 4 makes it positive 4. And that's it. That's it. Question on this here? Question on anything we've done so far? Now, a lot of what's making this nice is these general forms, because as long as we stick to the general form for each one of these transformations, it makes things go a lot smoother. Let f of x equal the absolute value of x minus 5 minus 4. Write a function g whose graph is a reflection across our y-axis, a reflection in the y-axis of the graph of f. Well, g of x, or not g of x, but our reflection in the y's general form is f of negative x. This time, we don't just have f of x anymore, we have f of negative x, which means every x in our f of x is going to have to be replaced with negative x. Since we replace this x with negative x, all the x's over here have to be replaced with negative x. So g of x, do we need the parentheses around the negative anymore? Negative x, no, and there's not a number or sign in front of it. So we just get g of x equals the absolute value of negative x minus 5 minus 4. Questions on this here? We're good with this here so far. How do we feel with these reflections across the x-axis and y-axis? We feel comfortable with these here? Does anybody need to see another example of one of these? No? No? We're good? All right. Because reflections across the x and y are kind of nice. And yes, I do need to fix those slides. They've gotten way too blurry or pixelated. But the only other ones that we have left are horizontal stretch and shrink and vertical stretch and shrink. Now we're going to talk about vertical stretch and shrink first. Now the vertical stretch or shrink general form is a times f of x. If it's a vertical stretch, we're going to use a times f of x. If it's a vertical shrink, we're going to use a times f of x. We have the same general form whether it's a shrink or a stretch vertically. Doesn't matter which one it is, we are going to have the same. Because what we're doing is multiplying the outputs, the y values, by a stretches. Multiplying the outputs by a stretches the graph vertically away from the x-axis, where a is greater than 1, and shrinks it when a is between 0 and 1. That's kind of nice. So it doesn't matter what the stretch or shrink is. It's the value of a. We plug it into a times f of x. Nice, easy, to the point. Horizontal stretch and shrink. Our general form is f of a times x. stretch, shrink, flip the value before you plug it in. This is the only one that has a real hitch to it with doing these here. Because if we look at the general form, yes, we have f of a times x is a horizontal stretch or shrink by a factor of 1 over a. We have to flip it, is all it's doing. Because if we said a was 1/2, well, it's saying 1 over a. So 1 over 1/2 is 2. What happens if I flip 1/2? It becomes 2 over 1, which is just 2. If we said a was 3, okay, 1 over 3 is 1 over 3. We just flip 3 to 1 over 3. Flip the fraction, and that's our value. So horizontal is the only one that's tricky because we have this factor of 1 over a. We're flipping the value of a, whatever it is. And that's the reason it's tricky. It's not so that it's hard or more challenging. We have to remember to flip it with horizontal stretch or shrink. All the rest of these work for applying these transformations work like they are. Up, down. Up's positive, down's negative. Left, right for our value of h. Right's positive, left's negative. We plug it in, and especially with horizontal, the sign changes back the way it's supposed to. Reflections, negative f of x, f of negative x. Vertical stretch or shrink. That is exactly what it looks like. But horizontal stretch or shrink, we've got to flip it. We've got to flip it. So if we look at this first one here, let f of x equal the absolute value of x minus 3 minus 5. And we want to write a function h of x whose graph is a vertical stretch of the graph of f by a factor of 2. Now for us here, our value of a is 1. So what's our value of a? A is 2. It's the amount we're stretching it vertically. Or shrinking it vertically. Vertical stretch or shrink is exactly what it is. A is 2. Our general form for this is a times f of x. You can put the multiplication dot there if you want. Don't have to have it. A times f of x. A or multiplication dot f of x are the same thing. Now what's our value of a? 2. So we have 2 times f of x, or 2f of x. We're multiplying f of x by 2. Questions on this here? Well, now we need to replace f of x with its function, yes? Absolute value of x minus 3 minus 5. Questions on any of this so far? Questions on anything we've done so far? Now the next step is going to be essentially the same thing we did with reflection across the x-axis, but instead of multiplying through by a negative, we're multiplying through by 2. So the 2 will multiply by the number in front of the absolute values, which would be 2 times the absolute value of x minus 3. And then we'd also have to do 2 times negative 5, which would be negative 10. Now there are no other like terms, so we get that h of x is equal to 2 times the absolute value of x minus 3 minus 10. Questions on this here? What do we think is vertical stretch and shrink so far? Not too bad. All right. Let's look at the next one. Let f of x be this here. Write a function g whose graph is a horizontal shrink of the graph of f by a factor of 1/3. Now, horizontal stretch or shrink would be f of a times x. Now, since it is horizontal, before we can find our value of a, we've got to take the factor they gave us and flip it. So if we flip 1 over 3, it becomes 3 over 1. So our value of a is what? 3 over 1 or just 3. Questions on how this works? Because unfortunately, there's not a whole, most of the reasoning behind it's a little weird, it's a little funky. But to find this value, this stretch or shrink that we're going to apply to it, we have to take whatever factor they give us and flip it. So 1 over 3 becomes 3 over 1, telling us our value of a is 3. And we can plug that in. So the function that we're applying, or what we're applying to the original function, is this 3x. So what we're going to do for this next step is take every x in f of x and replace it with 3x. So we'll still have the absolute value bar, but instead of x, we now have 3x. We still have the minus 3, absolute value minus 5. Well, there's not a number or sign in front of our 3x, so we can drop the parentheses. Telling us that we have the absolute value of 3x minus 3 minus 5. Questions on this here? Are you ready for the next one? Write a function whose graph, write a function g, whose graph is a horizontal stretch of the graph of f by a factor of 5. Now again, we're talking about horizontal, which means we need to take whatever our scale factor is and flip it. So if we flip 5, we get 1 over 5. So our value of a in this case is 1 over 5. And we would use that 1 over 5 in our general form. Because the general form for a horizontal stretch or shrink is f of a times x. Which for us here, we'd be saying that g of x is equal to f of 1/5 x. Questions on this so far? Now again, just like the previous ones, just like the last one we did, we don't have f of x anymore. We have f of 1/5 x, which means in our function f of x, we have to replace every x with 1/5 x. We still have the absolute value bar, but instead of x, we have Come on. Okay, that's 1/5 x minus 1 plus 2. And since there's nothing in front of the 1/5 x, we can drop the parentheses, telling us that our final function is the absolute value of 1/5 x minus 1. Questions on this here? We ready for the next one? Are there no questions on any of this so far? All right. Let's look at this one here. F of x equals the absolute value of x minus 1 plus 2. We want to write a function h whose graph is a vertical shrink of the graph of f by a factor of 0.25. Now the general form for vertical stretch or shrink, h of x is equal to a times f of x. Well, our value for a is going to be what? 0.25. Since it's a vertical stretch or shrink, there's nothing that we need to do to this. We don't have to flip it. We don't have to do anything to it because it's a vertical stretch or shrink. Now, if it's a horizontal stretch or shrink and they told us it's 0.25, we might need to grab the calculator to help us out a little bit. So that'd be 1 over 0.25, or become 4. Because 0.25 as a decimal is 1 over 4. So if we flip it, it becomes 4 over 1. But here, it's not asking for that. It's asking for horizontal or vertical. So the first thing we can do is replace a with its value, which tells us that we have 0.25 times f of x. Again, just like the previous ones, the next thing we can do is replace f of x with its function, which would be the absolute value of x minus 1 plus 2. This is still h of x. And the last thing we need to do is multiply through by our 0.25. Now, when we multiply this term by the absolute value, we will not multiply through it. We'll just multiply by the number in front of it. Which in this case just becomes 0.25 times the absolute value of x minus 1. And we also need to do 0.25 times 2, positive 2. So the positive times a positive will still give us a positive, but we still need to multiply 0.25 times 2. Anybody know what that is? Mm-hmm.
I just didn't want to be wrong. So
No. Nothing wrong with being wrong. We can always fix it. Yep, because we have 2 quarters. So it makes 50 cents. Questions on any of this here? We ready for the next one? We're going to do one more. I think we got more than enough time. Yep. One more vertical, one more horizontal stretch, and then we will finish this up tomorrow. So this one here. Write a function g. So they told us to use g of x for both of these here. Now this first one here, they give us the function f of x equals the absolute value of x minus 3. And we want to apply a vertical shrink by a factor of 1/3. So vertical stretch or shrink, just like the last one we did, is a times f of x, a f of x. You're here in the hand dryer.
No, I'll get something else. I'll make something. Get something.
Possibly. Because that wall right there is the shared wall between here and the bathroom.
Yeah, probably.
Yep. So, yep. I would not mess with that carpet over there if I were you. Because y'all remember, I think last year towards the end of the year where the boys' room flooded, it came under that wall. Yep. Yeah, so I definitely would not eat anything off this floor. Now for this one here, what's our value of a? One-third, 1/3. Since it's vertical, we don't have to do anything to it. Since we have our value of a, we can replace a in our general form with its value. So now we're saying 1/3 times f of x. And the next step would be replacing f of x with its function. So we have 1/3 parentheses absolute value of x minus 3. And the last thing we need to do before simplifying, if we need to simplify, is to distribute this 1/3 to every term in our parentheses. Well, our 1/3 times the absolute value of x, well, it's not going to multiply inside, so it'd be 1/3 times our absolute value of x. Now, since our 1/3 is positive and we're multiplying it by -3, it would still be negative. But now we need to do 1/3 times 3. And what is 1/3 times 3? 1. 1/3 times 3 is indeed 1. So we would have -1. So our new function with the vertical stretch of 1/3 is 1/3 times the absolute value of x minus 1. And that's it. And now we have the last one of the day. We want a horizontal stretch by a factor of 2 for this function here. And again, just like the one before, we're going to use g of x. And that's fine. Y'all can watch this one here. Because I've changed these around a few times, so I think I forgot to add it back. All right, let's get my... Now, they tell us functions 4x plus 2, horizontal stretch by a factor of 2. Since it's horizontal, we can't just take the 2, we have to flip it. So the denominator is now 2, and the numerator is 1. And just like we did on the previous ones, we can plug that 1/2 in for a. giving us this here. And just like the ones we did before, we're going to place every x in f of x with 1/2 x. So we would still have the 4 times our 1/2 x plus 2. Now the only thing we have to do here is multiply the 4 and the 1/2 x. Well, 4 times 1/2 is 2, x plus 2. And that's it. And we're going to stop